in physics and in chemistry, it's good to have a mental picture of what matter looks like at the smallest scales. This is particularly useful when we study thermodynamics and sound. So as you probably recall from chemistry class, an atom is the smallest division of a pure substance that still retains its characteristic chemical and physical properties. An atom consists of a nucleus that's very, very small with electrons kind of orbiting around that nucleus. And the usual cartoon-looking picture you see is something like this with electrons in kind of circular orbits around this nucleus. That picture is not very accurate at all, but it's easy to draw. In reality, electrons don't move in circles, they move in clouds of probability that have interesting shapes. You might have seen electron orbitals in chemistry class, and you know that they come in all sorts of crazy looking shapes. And the nucleus here is not drawn to scale, it's way smaller. If I drew it to scale, you wouldn't even be able to see it on this board. The nucleus is where you have two types of particles, protons and neutrons. Electrons carry a negative electric charge, protons carry a positive electric charge, neutrons carry no electric charge. Now, protons and neutrons are built out of smaller objects. Those smaller objects are called quarks. A lot of these names in physics are kind of silly or whimsical. There are 31 known fundamental particles that are the smallest known building blocks of matter. Electrons are one of these fundamental particles. As far as we know, electrons can't be broken down into anything smaller. Protons and neutrons are not fundamental particles. They're composed of quarks, and there are several other fundamental particles, and the branch of physics called particle physics studies this. And the standard model of particle physics is this quantum field theory that describes all of the known particles and their interactions. So keep in mind this mental picture of an atom. In Physics 7, when we start learning about quantum mechanics, we're going to revise this picture. But as far as studying thermodynamics and sound, this picture is good enough.